In this video, let's go ahead and take a look at a couple more properties together. So at this point, hopefully you have learned about the commutative property where you can switch the order with multiplication or addition, as well as the associative property where you can change the grouping for addition and multiplication, as well as the identity property of multiplication and addition, where you could add 0 to an expression and it'll stay the same, or you can multiply an expression by 1 and it'll stay the same, as well as the distributive property, where you can also rewrite a sum or difference as the product of a value with a sum or difference. Now, in this particular video, we're going to be taking a look at two specific properties to kind of add into the mix here. The first one is going to be the additive inverse property. That just says that if you add two opposites, you will always get 0. And then there's the multiplicative inverse property, which just states that if you multiply reciprocals with each other, you always get 1. All right, let's jump right into it. In questions 1 through 6, let's just go ahead and check off if each of the following expressions represents the additive inverse property, where you add and get 0, or the multiplicative inverse property, where you multiply and get 1, or neither. All right, so for number 1, we have 4 plus negative 4. Those are opposites, so if you're going to add those, you're going to get 0, right? So if that's the case, you can say that this would represent the additive inverse property, right? We're definitely adding. For number 2, this one's a little bit trickier to kind of look at. Typically, when you're thinking about multiplication and reciprocals, you're writing as fractions, right? But if you multiply these out, there's two ways to kind of think about this. You multiply the 25 times 4. I'm going to ignore the decimals for a moment and multiply, and then just put the decimals back in. That's going to be 20, and then 8 plus 2 is 10. And then let's see, we have two decimal places that we ignored. So if we go ahead and put those two decimal places back in, we're looking at 1.00. So since this does equal 1, this is representing the multiplicative inverse property. And another way you can also think about this is if you think about that 0.4 as 4/10, that's going to be 4 over 10. And then if you think about the 2 and 5/10, that's going to be as a mixed number 2 and 5/10, right? Now, 4/10 can be simplified down to 2/5, right? And then the 2 and 5/10, that's really just 2.5. So 2.5 as an improper fraction is 5 over 2. So you actually, if you turn them into their fraction versions, you can see that these are indeed reciprocals, and if you multiply together, you do get 1. For number 3, if you take a look, we have 4/5 plus 5/4. Now, these are reciprocals, right? 4/5 and 5/4. If you multiplied them, you would get 1. However, notice how we have an addition sign here. So you can see here that if you were to add these, you would not get 0, which would be necessary for the additive inverse property. So for this particular one, we're going to go ahead and say neither. And this is just because I'll go ahead and say this does not equal. If it's adding, it has to equal 0. So this does not equal 0. Maybe we'll go back to number 1 and actually say 4 plus negative 4, say that's 0. So that's also why we know it is the additive inverse property. We're really looking for 0s and 1s here, right? For number 4, this time we actually don't have any values, we just have variables. So the negative a times b plus positive a times b. If this is confusing, go ahead and make up hypothetical values for a and b. But if just say we said a was equal to like 5 and b was equal to 4, then this would be negative 20 if you multiplied, and this one would be positive 20. Now what happens if you add negative 20 and positive 20? That does equal 0, right? So if it equals 0, that means this does represent the additive inverse property. Now, you can come up with other values for a and b also, and it will work no matter what you're choosing, right? For number 5, this one has variables again. So we have 1 over x multiplied by x. Well, you can also think about this if you'd like to as 1 over x multiplied by x over 1, right? Because x seems to be a whole number here. And then if you go ahead and multiply, the x's can cross cancel, or you can just say it's 1x times 1x, use the identity property, get rid of those 1s. Then anything over itself, x over x does equal 1 here. So this must represent the multiplicative inverse property, because you get 1 if you multiply them. You could also substitute in values for x here and say it's like 1 over 5. If you're saying x is 5 times 5 over 1, and that does equal 1 as well. So you could come up with hypothetical values to test as well. All right. For number 6, let's go ahead and see. We have these fractions. It's kind of hard to tell if they're reciprocals right now. I don't really feel like multiplying the 14 and 24 and the 21 and 16. So let's go ahead and just kind of simplify these fractions. So 14 over 21, their GCF is 7. If you divide by 7, you're going to get 2 and 3. And then this 24 and 16, I think their GCF is 8. If you divide them both by 8 on top and bottom, you're going to get 3 and 2. Oh, surprise, surprise, these are reciprocals of each other. The 2s and 3s can cross cancel. or you can just multiplying it 6 over 6, which is 1. So this does represent the multiplicative inverse property. All right, cool. Let's go ahead and try to simplify and evaluate some expressions here, justifying each step with one of our algebraic properties as well. All right, so we got to make sure we're going to use the commutative property, the associative property, the identity property, distributive property, but also an inverse property at some point as well. Okay, so looks like we have an original expression. It's algebraic. Now it is a numerical expression once you substitute in each of these values that we are given over here. After substituting, let's go ahead and rewrite all the differences as sums. So if we go ahead and do that, we will have here -4 multiplied by 2 plus -5. And then instead of saying minus a -4 times 2, we can actually just say this is going to be plus a +4 multiplied by 2, right? Just less symbols here, and you would get the same thing either way. If you didn't do that, that's fine. Later, if you kept this as a minus sign, this would eventually be -8. So taking away -8 would be the same thing as adding an 8 later, which is really what we're doing here. All right, let's go ahead and distribute now. If we distribute this -4, let's go ahead and multiply by each of these terms inside here. -4 times 2 is going to be, actually, let's just rewrite it and keep it as -4 times 2 for a moment, plus this -4 times -5, and then plus this 4 times 2. And the reason why I kind of just paused there instead of actually multiplying it out is just going ahead and looking ahead. It says in the next one, it says order of operations, and it says find all 3 products. So I think we're being asked here to just go ahead and find these products right now. So -4 times 2, that's going to be -8. And if you're following the order of operations, you would do this multiplication next. So we're just doing them all at the same time right now, but from left to right still. -4 times -5 is going to be +20. And then we have finally this 4 plus 2, which is going to be 8. Okay, so the next thing we're going to do is order of operations. Let's see, if we look down the line and we see we're going to use commutative and associative at some point, I think we're going to be inserting grouping symbols here, right? Otherwise, we can't use the associative property because we have no parentheses to move. So let's go ahead and insert parentheses here, or brackets, as I'm just going to put, just to make it maybe a little bit more clear. This is order of operations. We would go left to right. Commutative property next says we would swap the order. So the only thing we can swap here is what's coming first, which is what's inside here. So it's going to be 20 plus -8. And then once we have applied the commutative property, hopefully you can see the goal is to get the -8 and +8 together, so we can use the additive inverse property. But let's just get to that step first. Associative property, let's go ahead and move those brackets. So let's keep the 20, leave it alone here. Let's move the bracket, or what's being associated here, and say this is going to be -8 plus +8 here. And that will stay in the brackets together here. All right, the additive inverse property we can apply here because these are opposites. So -8 plus 8 is 0. So we're really looking at 20 plus 0 here. And then 20 plus 0, if we apply the identity property of addition, 20 plus nothing is still going to be 20. So this would be the most simplified expression. And I think we've used all the properties we were supposed to use. All right, let's try another problem here. This time for number 8, we're going to try another one here. Looks like we have h, j, and k as our 3 variables. Here's our original expression, so we'll just go ahead and write that first. Let's go ahead and now substitute in our values. So let's go ahead and say k is 6. So we're going to say 6 minus, and we have this 2 multiplied by, and then j is -7. So we'll substitute in -7 here plus h. H looks like it's going to be 3. Okay. But we're going to go ahead and apply our understanding of each of the properties to demonstrate that we can apply them in a logical and clear way and still get to the same result here. Okay, so let's go ahead and rewrite all the differences as sums. So instead of writing -2, we'll write plus a -2. But I think that's the only difference we had to rewrite here, right? Everything else is already a sum, so that's good. Next, we're going to go ahead and distribute this -2 to both of these terms over here. So let's see, -2 multiplied by -7. Go ahead and just keep it like this for a moment. Looks like in the next step we're going to be multiplying anyway, so we'll just leave it alone for now. -2 times 3. It says next find both products, so we have 2 products here. We'll do 6 plus, and then -2 times -7 is 14, and then -2 times +3 is going to be -6. Okay. Next, it's order of operations. So in order to use those properties later, we're going to need some sort of grouping symbol. So I'm going to group the first 2, just because we have to go left to right here by default, and then leave this plus -6 on the outside. And then commutative property, let's go ahead and just swap what's inside here. So instead of 6 plus 14, we'll say it's 14 plus 6, and then leave this plus negative 6 on the outside. Next, the associative property, let's get the 6 and negative 6 together just because they're opposites, right? Let's go ahead and move that. So we have this 6 plus negative 6. We'll go ahead and put those in the brackets together here. And then let's see, the additive inverse property, or just order of operations, but more specifically additive inverse property, opposites add to get 0. And then the identity property of addition, 14 plus 0 is just 14. So step by step, that's how you would evaluate this expression if we wanted to use all those different properties the correct way. All right, let's just try one more problem here. This time in number 9, let's go ahead and use the properties that we know. This time you're going to see there's no distributive property. However, we are going to be dealing with some products here instead, right? So let's see, we have some values of w, x, y, and z. Looks like we have a lot of fractions or rational numbers here. And looks like we actually don't have to do any of the math part. We just have to make sure we can justify what we're doing. So let's look at each step and see what is going on. We have the original expression right over here. And then how did this expression become this expression right here? Well, looks like all the variables were turned into their values. So we're just going ahead and write substitute values. All right, pretty straightforward. Next, it looks like these brackets were inserted around the first operation. That's just order of operations. But how did this step turn into this step over here? Well, what's the only difference? Well, all the fractions are in the same location, but it looks like these brackets over here changed locations here. So what's that called? That's called the associative property. And remember, there's addition and multiplication. In this case, we're multiplying those, so it's got to be multiplication. All right, next let's see, how did this line become this line? Well, looks like everything's the same except this middle part became 1. Well, how did that become 1? Well, I think we just did order of operations, but specifically if you multiply and get 1, that is called the multiplicative inverse property. All right, that just means that if you multiply and you get 1, specifically when they're reciprocals, you do get 1 after you find the product. All right, let's see, moving on here. Looks like from this step to this step, the only thing that changed was these brackets were inserted. That's just order of operations, great. And then let's see, how to get from this step to this step. Well, everything looks pretty much the same, except these kind of did some swapping, right? So what's that called? That's called the commutative property of multiplication. All right, let's see. Moving from this step here to this step, it looks like the only difference is that the brackets moved locations here. This is the associative property of multiplication here. So let's go ahead and just take this one right over here. I'm sorry you can't do this, but I'm gonna go ahead and put that right here just because it's the same property we used earlier. And then let's see, 4/5 times 5/4, that somehow turned into this 1 here. So wait, that's actually the multiplicative inverse property, which we used earlier. We're using it again over here, okay? And then finally, 1 times 1, sure, you can say that's 1, but how can we say that? Or we can justify it by order of operations, but can you be more specific? Yeah, I think that's just going to be the identity, all right, identity property of multiplication, right? Anything times 1 stays the same. All right, cool. So there you have a few different practice problems. Hopefully most of it was a little bit more review just because we kind of just went over some of the older properties again, but just kind of wanted to clarify and go over 2 more properties so that we can kind of understand how the opposites and reciprocals, what kind of role they play as well, and practice using them in these expressions. So if you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.